Somebody once said, you can't control what you can't measure. So if we have no way of getting any feedback from our process, how are we ever going to manage the software development process properly? Okay? So metrics is involved with providing this feedback to project managers, to software managers, to software developers, just telling us how things are going. It's the only way that we can ever hope to achieve any degree of control over the software development process. We're going to start with some definitions, and then we'll talk about the use of metrics and just some advice about how to start up a new metrics program if you wanted to do that. Now, the difference between measurements and metrics is sometimes confusing. I'm going to use the terms in this way. A metric defines something to be measured. A measurement is a value that you obtain when you apply that metric, when you actually do the measurement of that metric. So the metric defines something to be measured, while the measurement is the actual value itself in process. Okay, there are two kinds of metrics, software metrics, that I would like to talk about. One is process, the other is product metrics. Okay, the process metrics measures something about your process that you're using. And these are of more benefit perhaps to project managers and managers because they have to manage the process. There's product metrics. This is measuring something about the product. And certainly the software development people, the quality assurance people are interested in the product metrics as well. Software product metrics, some examples, complexity. Okay? How many connections are there between the modules, dependencies, and things like that? Okay? Hopefully we have a small number of dependencies and they're well managed, and we have the localization, we have encapsulation going on. So if you can actually produce metrics that will evaluate how much encapsulation is happening just by looking at the references between pieces within one module and other modules. Reliability metrics. We'll talk about reliability in a little bit, but it's measured in terms of mean time between failures. How likely is this software to work properly versus how likely is it for the software to fail? That would be a reliability metric. And usability metrics. We talked about usability when we were talking about human-computer interfaces, and we could measure certain aspects of the usability of the software. In terms of, for example, how long it takes somebody to learn how to use the software. That would be a measure of like how easy is it for it to learn, how easy is it for people to actually use the software to do their jobs. Okay? Those are just some examples of metrics that we could apply to software. I mean, the oldest software metric in the world is lines of code. You can counting lines of code. That's counting how much software we have, how much volume. Function points. Right? That's another aspect of software. That's a metric that we can actually very precisely measure. There are two kinds of software metrics, product metrics. One is static, the other is dynamic. A static metric we can measure by looking at the software or the design or whatever it is without having to run the software. Okay? You can measure things like count lines of codes. You can count look at complexity. You can look at actual references. You can look at other aspects of the software, function points. You can count that. Okay? Those are static metrics. Dynamic metrics, you actually have to run the software in order to measure these things. Things like reliability. You can't test reliability. You can't look at the software and say, hey, this is reliable or it's not. You actually have to run the software and actually time to see how long it'll run before failures, right? And you plug the numbers that you get into some reliability model. Usability, generally, you can't test until you actually run the software and have people actually use the software to see whether or not it's usable. Right? So there are static metrics you can put these counters into your tool set, but your library system could have metric tools in it. Your compiler could be outfitted with metrics tools to measure the static aspects of the software. But the dynamic, you actually have to run the software. In some cases, for example, you might want a histogram to see where you are spending the most amount of your execution time. in which modules. This would be helpful if, for example, when we want to look to maybe optimize for performance, it would be useful to know, well, where, could we, what parts of the software should be optimized for performance. There's a normal, what's called a Pareto effect, 80-20 rule. It says that software generally spends about 80% of the execution time in a roughly 20% of the modules. So you'd like to find, well, where are those, which 20% of the modules are the ones where the software is spending most of its time, and let's focus on those in terms of doing optimization. So you don't waste your time optimizing some part of the system that's not, that you won't get a very big return on an investment for optimizing. That you need to do dynamic metrics. You actually have to instrument your runtime system, or some have a test suite or something to measure the amount of time that you're spending in various pieces of the software. That's a dynamic metric. Reliability is a dynamic metric. You actually have to run the software and see how long it takes before it fails. Now, as we're running tests on our software, we find the defect, we fix the defect, and hopefully it'll run longer amount of time the next time we try to run it before it fails. And so as testing proceeds, as we do more and more testing and fix defects, the defect rate hopefully will decline. Hopefully the defect rate goes down in sort of probably a hyperbolic fashion like this. As the defect rate goes down, the expected mean time to the next failure should go up, right? Because it's less likely that you'll run into a new defect. Right? So as the defect rate goes down, the likelihood of having another failure because of another defect will go up. So the mean time to the failures goes up. Now, you could actually establish a goal for your testing to say, well, based on XYZ reliability model, and there are hundreds of them, we say we can declare success with our project and stop testing after the mean time between failures on that particular model, or maybe the average on a number, some number of reliability models, after it reaches a certain point. Okay? And so that would be a nice objective way to say to declare when you are done with your testing, based on mean time to failures. And otherwise, how do you know when you're done testing? I mean, you probably will never find the last bug and the proverbial final defect. It's not there. There are always defects lurking in your software, and so probably the most objective way to determine when you're done with software testing is based on some reliability model. Software process metrics measure aspects of the process. Things like productivity, right? How productive are our programmers? How many lines of code per person month is a typical way of measuring productivity. How many function points per person month? How many modules per month? How many use cases per person month? Things like that. Those are productivity. Manageability measures how effective we are in managing the project. And one aspect of this is predictability. When we do an estimate, and then of how much it's going to cost or how long it's going to take to do something, and then compare that estimate back with the actual, the closer they are, the better your manageability is. Right? So you can measure how easy or how effective we are at managing projects. Scrap and rework. In quality circles, scrap and rework are negative costs. They cost. They make us charge extra for our products. Okay? In a manufacturing world, at the end of the assembly line, you test the products, and if they don't meet spec, then you have two choices. Either you scrap them or you rework them. Now, the decision is made based on how expensive it is to manufacture the product. If I'm making nuts and bolts or something like that, right, and they come off the assembly line and they don't meet spec, generally what we'll do is we'll just throw them in and melt them down and scrap them. We'll make new products out of them. In some cases, you just throw the product away, just scrap it. But usually, quite frequently, we can reuse the materials in making new products. However, if I'm building, I don't know, TV sets or something like that, and they come off the end of the assembly line and they don't meet spec, generally we don't scrap them or throw them away. But what we'll do is we'll send them off someplace and they will fix them, they will repair them, and then they'll market them as refurbished equipment. So we sell them at a discount, but we still get something out of the expense of actually manufacturing plus reworking the product, plus we sell it at a cheaper price, but still we're making some money, right? We're not totally losing everything. So the decision between whether you do scrap or rework basically has to do with can it be fixed and how much will it cost to scrap it versus reworking it. Now, once again, we have static and dynamic process metrics. A static process metric is one that we can just count things. So we can say, well, how many things need to be reworked? How many things need to be scrapped? How effective were our estimates? What's our productivity? That is a static metric. It's a point in time. Now, a dynamic metric shows trends. For example, we could say, well, let's look at our productivity now and every week and see how our productivity changes over time, or our manageability, or our scrap, our defect rates, right? How do they change over time? And we can plot these things on like line graphs and chart our progress. Hopefully, things like quality, the defect rate is going to go down. Things like that. So we can do both dynamic and static software process metrics. Now, how would these metrics be used? Well, there are proper and what I would suggest are improper uses of metrics. I mean, the whole idea of metrics is so you get a handle on how things are going. You could use it for example, for continuous process improvement or statistical process control. What this means is statistical process control, for example. What it means is in order to manage the process, we have to have feedback. That's through metrics. So we'll use the metrics to make decisions about how to run the project. That's called statistical process control, controlling the process through feedback from metrics. Continuous process improvement says not only will we use the metrics to control the project, but we will try to modify our process so as to optimize the metrics, to improve the metrics. Okay? And so you can say, well, not only am I going to manage, but I'm also going to try to modify the process in such a way that a particular metric is optimized, is improved. And you can watch these in this trend analyses. You can see as you make changes to your process how certain metrics are improving. And so you can use the metrics for continuous process improvement. Now, if you go back to the capability maturity model that I referred to before, CMM or CMMI, it's a 5-level scale of sort of maturity of processes. And level 4 says one of the key process areas in the level 4, which is pretty high, it says the organization will use metrics to control the projects. Okay, it's called managed. Level 5, the top level, says not only do they use metrics to control the process, but they also use metrics. They try to optimize the process to continuous process improvement to optimize the metrics. It's called the optimized level. And so you're trying to optimize the metrics at level 5. That's the highest level of the capability maturity model. Now, what would be some what I call improper uses of metrics? Well, if you try to use the metrics to measure people, or in fact, if the people think it is they that are being measured and not the process or the product, then they're not as likely to give you the results you're looking for. If people think that it is they that are being measured, then they're likely to skew the metrics somehow, right? Certainly, if the metrics are manually taken, then they'll just lie. They won't report accurate measurements. Now, even in the case where the metric is automatically measured, they can do certain things to skew those metrics. And because they have a vested interest in improving the metric. Right? So you really have to establish the fact, when you're doing a metric program, is to say to the people, hey, I am measuring the product or the process. I am not measuring the people. And there's no way that we can attach a measurement to a particular person. Now, for example, one of the metrics might be Number of defects per inspection. Well, you have to be very careful now because, if my work product's being inspected and somebody is keeping track of number of defects per inspection, then if that ever could get back, to be attached to me, then I'm less than likely to want to have my stuff inspected. So these kinds of metrics usually need to be sort of folded up at the higher level. So you'd say, oh, for a whole organization, how effective are we in doing like inspections and things like that. So you can't attach any metric, or it should be impossible to attach a metric to a person. If you don't, if people get this idea that it's they that are being measured, the metric program is going to fail. The other thing is setting arbitrary measurement targets. So when I'm starting up a measurement program, a metrics program, if I don't know what the target is, then I shouldn't guess. I shouldn't guess at what the target should be. I should just use the metrics to evaluate things, get some feedback about how things are going, and then later on I might set targets, but don't set them arbitrarily. Use your actuals to see where things are now, and then try to improve those by changing the process, doing this continuous process improvement. Talking about setting up a new metrics program, how do you go about figuring out, well, which metrics do we want to take? I can think of two ways. One is good and one's not so good. The not so good way is, let's do some, read the literature and come up with a couple of hundred different metrics that might be useful, and we'll just measure everything. And then after the fact, let's see which of those metrics gave us some useful information. Of course, the problem with that is you're going to get bogged down in the metrics process, and you're not going to get good results from anything, and you're not really going to be able to tell which metrics were useful and which were not. You're just going to have too much data. You'll get inundated with all that information. Right? The better way to establish a metrics program is to figure out which metrics would be useful. And one good technique to do this is called the goal question metric technique. You can read about that. You can Google that and see a couple of papers on that. First of all, what you do is you decide what are the goals for my project. For example, maybe one of the goals would be to increase customer satisfaction. Right? And then you say, well, for these goals, these 5 or 10 or 15 goals, whatever it is for my project, I say, what kinds of questions should I be able to ask such that if I knew the answers to these questions, I could determine whether or not I had satisfied the goal. Okay. For example, improving customer satisfaction, maybe I would say, well, how happy are the customers? What kind of repeat business do I have? What kind of have the customers returned products? Stuff like that, right? And so then you'd say for each question, you could say, well, how could I determine the answer to the question? Are the users happy? And then you'd establish some metrics that you could actually go out and measure. So you could look at frequency of warranty usage, or frequency of returns, or you could do happiness surveys. As long as they're statistically significant, you can do out the J.D. Powers kind of thing, where they interview lots of people, lots of customers, and see whether they like the service. Right? So you could do metrics to support the questions, to help you answer the questions. The questions can determine whether or not you're meeting your goals. If you can devise the set of metrics needed to support that, ultimately the goals, then that would be a good way to come up with which metrics would be useful. And only those, right? So you're not going to measure stuff just for the sake of measuring things. You measure aspects of your project or your process or your product to see whether or not you're meeting your goals.